Welcome. Within your integration flow, you can delay processing for a specified time with a wait action. Let's take a closer look. Let's first assume that you have an integration flow that has several actions and invokes that need to be executed in sequence, but due to business requirements or other downstream dependencies, you wish to delay the execution of next step for a specified period of time. Here is where you can insert a wait action, then configure the amount of time the integration should pause before continuing on. You have two options when configuring the wait time. The first is to enter a static literal value in seconds, and the other is to provide an XPath expression which must return a value for the number of seconds, thus allowing for a dynamic time period. As shown in this example, a common approach is to define an integration property and use its value in the expression, which then allows you to update the value later on, which of course requires a reactivation of the integration for it to take effect. However, either way, you need to consider that the wait time cannot exceed the total running time of the integration instance. For example, consider that synchronous application integrations will time out after 5 minutes, so it must be less than that. But even with schedule pattern and asynchronous application integrations, you certainly don't want to set a wait time that would cause your maximum design runtime for that integration instance to be exceeded. Here, the use case is to temporarily pause the integration flow, delaying the next action execution anywhere from 1 second to several minutes or even a couple of hours as appropriate for the use case. While you can insert a wait action almost anywhere in your flow, a typical use case for this action is to invoke another external service with a defined delay from the previous activity, or more commonly, it's used within a looping construct, such as a while loop or a for each action, as shown here, to delay processing to an external service within each iteration of the loop. And during runtime, you can also track the status of the wait action on the tracking page through the tracking diagram and the activity stream for an integration instance that is in progress, or even return later to a completed instance to view the same information. So anytime you need to insert a pause in your integration flow, simply add the wait action and configure the wait time. That's it for this lesson. Thanks for watching. Welcome. In this video, I'll demonstrate the configuration of a wait action. For this demo, to define the wait time that should occur prior to invoking the ERP cloud, I'll show you how to create an integration property. Let's get started. So we'll take a look at this integration called Get ERP Account Info. And right now, there is no delay at all before we actually invoke to the ERP cloud. Now, right now, there's really no reason to put a delay, but let's just pretend that we have a use case where we need to wait a second or two, but we want to make that configurable. The way we're going to do that is to first add an integration property, and I'm simply going to call it wait time. And initially I'll put a value in of 1 for 1 second. Now to actually configure the wait activity, I'm going to insert it right here before the invoke. We go to Actions, Wait, and I can provide a meaningful name for it. Right now it's just going to be Demo Test. But for the value, I can either type a value in seconds if I wish, or we can use an expression based upon that wait time. Now that that's configured, I can save it. And let's now execute this integration to see what it looks like. We'll go ahead and activate it. And we'll run the integration. So for this first run, I'll click here. It shouldn't take too much extra time because we only added 1 second for the delay. So the rest of the time is the time it takes to get to the ERP cloud. There's our response, and there's the information in our activity stream. I can see that 1 second was the delay. Now let's run another example, but before we do, we're going to deactivate the integration, and before we reactivate it, we're going to change that property value. So I can click here, see that the default value is 1, and that is its current value. I'm going to change that to, let's make it 5 seconds. Now that that's changed, we can reactivate the integration. And let's do another run. And this time the run took a little bit longer. As expected, in the activity stream, I can see that the 5-second time was applied. Don't forget also that when you're doing monitoring, you can always go and look at more details if you need to. Now, our integration here is quite simple, but if I wanted to locate where that activity was, I can then click there on it in the activity stream. It can point me to, as you can see here, where that activity is. And that's it for this short demo. Thanks for watching. Welcome. In this lesson, we'll look at using the note action in an integration flow. Let's assume a use case where you're working on an integration that invokes a couple of external services. However, during your development and testing, you discover that you're going to need to retrieve some additional info from a database prior to invoking that second service. The issue is that while you know it is an instance of an autonomous data warehouse, for now, you don't have the required schema and credentials information in order to actually configure the connection for that activity at this time. So this is where you perhaps would insert a note action with some basic information to serve as a placeholder to remind you or perhaps someone else on your team to implement this logic later on. Once you're ready to continue with editing the integration, you simply delete the note action and configure the connection and invoke action accordingly to retrieve and use the data as needed downstream in the integration flow. Of course, that is just one use case. You can also use this action for other comments, similar to using sticky notes anywhere within the integration flow. The note action is a design time feature that has no impact at runtime. So, assuming you want to provide design comments to others to view later on, you can actually leave them in the integration even in production. Let's now take a quick look at using and configuring the note action. To configure, after placing the note action somewhere in your flow path, you just then provide a short name for the action. I'll call this Invoke Database. And then, of course, you can provide any description, comments, or information. I'm going to paste in this information about accessing the ADW instance, and then I simply click to save it. Now, later on, someone can go to this action to read it by simply hovering over it, as you see here, or they can use this menu to move it to another location. Let's say it needs to go here instead. and it moves to the new location. Or you can use this menu also to delete the action. So anytime you need to add comments or create a placeholder in your integration flow design, use the note action as needed. That's it for this lesson. Thanks for watching. Welcome now to Module 6, File Processing. These lessons cover all the many aspects of receiving, processing, and sending files in integration flows, from defining FTP and file adapter connections to configuring all the available connection operations. You'll also learn about the stage file action operations, as well as how to transform native file formats. And to interact with the OIC embedded file server, you'll learn about the new file server action. There's plenty to cover, and once again, after you've completed the videos, don't forget to take the Module 6 skill check. Keep going strong. Welcome. In this lesson, we'll cover the basic options you have for handling files as you learn about some fundamental capabilities. When files arrive to your integration flow instance, they are temporarily stored into a virtual file system. And in some circumstances, they are also parsed and brought into memory, but more on that later. The virtual file system stores all received files as well as new ones you may create within the integration, but only for that instance. Other instances that may be running at the same time or later on will have their own VFS. So then, while you use it to store files that you create or have downloaded, essentially this storage is ephemeral and your files are not persisted beyond the life of that instance. Now, for access, the stage file action has 8 different file operations that you can use to work with files located in the VFS, and we'll look at those in just a moment. So let's now pivot to talk about how we can receive files from external sources. There are several options. The most common pattern for retrieving files is to define a schedule pattern integration with a configured FTP adapter connection used to access an external FTP server or even the embedded file server. So based on a schedule, a new run will kick off and the FTP Invoke connection will be used to retrieve one or more files to be further processed. Or instead of a schedule to trigger the flow, another pattern is to implement a REST adapter connection as the trigger, with the interface designed to expect one or more file attachments. So then when invoked by a REST client, those attachments are received into the integration and can be processed as required. On the other hand, if the file is located in a shared file system, along with an installed connectivity agent, you can configure a file adapter connection to be the trigger. The agent will poll the file system, and when a new file arrives, it will be delivered to OIC, triggering a new integration instance. However, regardless of how your integration is designed to start, once it does, you can retrieve files at any time. Now, we just looked at the FTP adapter, and likewise, the file adapter can be used in the invoke role to fetch a file whenever you want to retrieve it. Or perhaps there is a RESTful web service that allows you to request files, which can then be sent as an attachment in the response. Or using the SOAP adapter to invoke a SOAP-based web service that returns a file as an MTOM attachment as the response. Additionally, there are some SaaS applications such as Oracle Commerce Cloud and Oracle Logistics Cloud that can respond with a file attachment when invoked from your integration. Another scenario would be to use the new object storage action to retrieve a file that has been staged in an OCI object storage bucket. But what about those use cases where you need to send processed files to external systems? And it doesn't really matter how your integration flow was triggered or how it started, the same options apply. Again, the most common use case is leveraging the FTP adapter to write the file to an external FTP server or the embedded file server. Or if it needs to be sent to a shared file system serviced by a connectivity agent, you use the file adapter. Or perhaps there is a RESTful web service that is looking to receive the file as a multi-part attachment. Or if it is SOAP-based, send it as an MTOM attachment using the SOAP adapter. Again, certain applications can receive file attachments when invoked, such as Oracle Taleo Enterprise Cloud receiving a resume or a candidate picture. Another use case is to send the file to be stored in an OCI object storage bucket using the object storage action. As to processing a received file or to create a new transformed file, as mentioned earlier, you will use one or more stage file actions to accomplish your implementation. These operations are used on files that have been received, with the read operations bringing the contents into memory so they can be parsed. These operations are used just prior to sending a file out to an external system, but as we'll learn in other lessons, there is overlap of processing capabilities between the stage file action and configured adapter connections for several of these operations. For example, the FTP adapter also provides the capability to decrypt and encrypt files. And finally, throughout our documentation and in these trainings, we call out the difference between structured files as opposed to opaque files. The reason is that when sending or receiving files by way of the various adapters, there are limits and different behaviors. For opaque files, you can download or send files of up to 1 gigabyte in size. Structured files have a limit of 100 megabytes, or if the adapter is being used in conjunction with a connectivity agent, the limit is 50 megabytes. And while both types of files will be staged in the virtual file system, structured files will also be parsed into the integration instance memory so their contents can be exposed. The actual structured files themselves are those that have had their contents defined by an XML schema, while opaque files can be unstructured, such as PDFs, image files, or a zip archive, or they could be larger structured files, but the structure has not yet been defined, and that is why we can download or send those files up to 1 gigabyte. In other words, undefined structured would be opaque as opposed to defined structured. Later, we'll learn how we can download or receive a large undefined structured file, then bring it into memory in defined structured segments to be processed. Or, of course, a zip archive could contain one or more structured files that could later be brought into memory to be processed as well. And that brings us to the end of this lesson on file handling fundamentals, but there is more to learn. So be sure to take a look at the additional videos that are in this module. Thanks for watching. Welcome. In this lesson, we'll look at the options you have for defining connections using either the FTP or file technology adapters. Let's get started. File adapters are configured to access a shared file system, while FTP adapters can be used to connect to an FTP server. The main difference is that since the shared file system needs a local client to access the files, a connectivity agent must first be installed. FTP adapters can connect with the remote FTP server directly and would only require a connectivity agent if the FTP server was located in a private network. As to file operations, these are the 6 operations available for both adapter types when used in the invoke role. File adapters can also be configured as a trigger for an integration flow, since the connectivity agent serving as a polling client will deliver new files to OIC, thus launching a new integration instance for each new file. Now, unfortunately, some folks are concerned to learn that the FTP adapter does not support the trigger role, as does the file adapter, and is not able to automatically poll to process new files that have been recently delivered. However, you can achieve that same capability with the FTP adapter by leveraging a schedule pattern integration. Using the Invoke role FTP adapter connection, the trigger can be triggered on a schedule, followed by an immediate list files operation call on the connection, next an action to see if there are any new files. If there are, then the connection is used again to download one or more files, followed by any downstream processing logic that needs to be implemented. The FTP adapter has various connection property options. Of course, you'll need to provide the server's host address and port. Then under optional properties, you'll see several fields you can edit, as well as the ability to upload a host key or SSL certificate, depending on the type of connection you need to use. For FTP protocol connections, you can only use the FTP service access policy, which uses the username and password for authentication. Then under optional security, if you uploaded an SSL certificate, you'll need to provide the password for that P12 format certificate. This policy also allows for the configuration of PGP values. For secure FTP protocol connections, you can choose to use any of these three security policies. So instead of just username and password, the public key authentication policy connects to the secure FTP server using the public host key you uploaded in the optional connection properties section. You still provide a username, but instead of a password, you upload the private key file. Then in the optional security section, you'll need to provide the passphrase if the private key is encrypted. This last policy option uses multiple independent credentials to log into the server, which creates an extra layer of defense against unauthorized users. With this policy, you provide a username, user password, and the private key, but also the private key passphrase, since the key must be encrypted. You will also configure the first authentication sequence to be either the password or the host key. And as a reminder, all three policies provide options for specifying PGP encryption and decryption and signing verification details. However, you will first need someone with the OIC Service Administrator role to upload those PGP keys into the OIC instance for you, so you can locate them here on this page. Finally, you'll need to indicate how the connection will be accessing the FTP server. In most cases, it will be a publicly available IP address on the internet, so you'll use the default public gateway. However, if the FTP server is running in your private OCI Cloud subnet, you can connect directly, but only if your OIC Service Administrator has set that subnet as a private endpoint for your OIC instance. Otherwise, the only other way to access a private FTP server, either in the cloud or on premises, is via an installed connectivity agent. In this case, you'd select that option, then indicate which agent group will be used. As to creating a file adapter connection, it is easy. Just indicate which role in which it will be used, trigger, invoke, or both. Then, as you can see, with no connection or security properties, you just need to associate the connection with the appropriate agent group, and that's it. Since both the file and FTP adapters have many overlapping capabilities, let's do a quick side-by-side comparison. The file adapter only works with an installed connectivity agent that has access to the file system, while the FTP adapter connects directly, and unless the FTP server is in a private network. The file adapter itself has no security configuration at all. Instead, the file system must be protected natively, while the FTP adapter has different connection security policies that utilize encryption protocols and supports key-based authentication for enhanced security. Only the file adapter can be used to trigger an integration flow, and while the supported invoke role file operations are the same, again, polling with the connectivity agent is limited to the file adapter. However, only the FTP adapter connection can be configured to support encrypting and decrypting files automatically during file write, read, or download, leveraging PGP cryptography without having to handle that within the integration flow. And one more consideration: if you wish to access the embedded file server within OIC, since it uses the secure FTP protocol, you can only use the FTP adapter. And so to wrap up, you use the file adapter to access shared file systems and the FTP adapter for FTP servers, both allowing for these 6 file operations, or you can use the file adapter as an integration trigger or leverage a scheduled integration pattern to accomplish similar logic with the FTP adapter. Now, that's it for this lesson. Thanks for watching. Welcome. In this two-part lesson, we'll take a closer look at the operations that can be configured on both the file and FTP adapter connections. Let's get started. So as a reminder, architecturally, the primary difference between these two adapters is that the file adapter requires a connectivity agent to serve as a client to the shared file system, where the FTP adapter typically connects directly using either the FTP or secure FTP protocol. The 6 operations for both adapters are mostly the same. However, as we take a deeper dive, we'll see that the FTP adapter provides some additional options when compared to the file adapter. We'll start with the list files operation, because this one is handy to use when you don't know the specific names of the files that you're looking to download or read into memory. Once you select this operation in the file or FTP adapter configuration wizard, you indicate which directory to list, as well as the file pattern of the files to be listed. However, later, when implementing the map action for this invoke connection, you have the opportunity to dynamically assign the value for the input directory or the file name pattern. If you don't, the invoke will use the values you specified in these fields. You also indicate the maximum number of files to be listed. However, this cannot be more than 1,000. Now, if you don't want to list any files that have been just recently created or modified, you can indicate the number of seconds to compare against the current timestamp. Otherwise, all files are listed. Now, checking this box will list all files recursively from the input directory, and for the FTP adapter, you can check this box to force the listing of all files regardless of the file permissions. When examining the response data structure in the sources section of the data mapper, of course, this will be available in the integration flow after the invoke. Keep in mind, this is not the files themselves or a list of file references. Instead, you're retrieving a list of file names along with some file metadata. However, to access this list for file processing, a common pattern is to then configure a for each action using this item count value to define the number of loops. Then within the loop, you'll see this additional data structure that will provide the name of the current file along with its metadata, allowing you to perhaps configure a download or read file operation next. When you select the move file operation, both adapter types will be looking for the directory and the name of the file to be moved, along with the target directory and target file name. You can also indicate if it's okay to overwrite the file if it already exists in that target directory. However, optionally, when configuring the map action for the invoke, you can dynamically provide values for any of those 4 fields. Otherwise, the default placeholder values are used. As to the results of this call, the response from the invoke will provide a Boolean true if the move was successful. The configuration for the delete operation is very similar, but here you only need to provide the directory and the name of the file to be deleted. And once again, optionally, when configuring the map action for the invoke, you can dynamically provide values for either of those 2 fields. As to the results of this call, once again, the response from the invoke will provide a Boolean true if the delete was successful. The download file operation is used when you need to retrieve a larger file up to 1 GB in size. For both the file and FTP adapters, once you specify the directory location and the name of the file to download, you then indicate where in the logical virtual file system you want to stage that file. Now, typically this will be in preparation for the next file processing action. However, for the file adapter, you also specify a transfer mode, binary, which only transfers raw bytes, or ASCII, which transfers special control characters for data formatting. Notice that the FTP adapter can unzip an archive file for you automatically if required. The file adapter does not have the capability, so you would need to do that with a separate flow action later if needed. The FTP adapter can automatically decrypt PGP encrypted files, or can also be used to perform a signature verification on the file. These require that additional private public key configuration when defining the FTP adapter connection. Again, if using the file adapter, you'll need to perform separate flow actions if PGP decryption or signature verification is required. Now, when editing the map action, both adapters provide for dynamically assigning values for the file name, directory, or download VFS directory. Of course, only the file adapter will include these Boolean processing options. Subsequently, in your flow, the mapping canvas will add this response in the sources section, where you will not only have access to the downloaded file reference in the VFS, but also have its file name, file type, and other metadata. Now, a common next step use case for larger downloaded files is to add a stage file action, configure a read file and segments operation, define the schema, then process those file records one chunk at a time as they are brought into memory. Another common scenario is when there are a bunch of files to be processed in a zip archive. After downloading and unzipping the archive, you add a for each action to loop through each file to process as needed. That brings us to the end of part 1. I'll see you in the next video where we'll cover the read file and write file operations. Welcome back to part 2. Now that we've covered the first 4 file operations, let's continue this lesson with the read file operation, which is similar but also a bit different from the download file operation. You may recall from an earlier lesson a discussion on structured versus opaque files. Structured files must be defined so they can be parsed into memory, while opaque files might have a structure, but if so, that schema is not defined and the file is not parsed into memory, which allows you to read an opaque file from a shared file system or an FTP server of up to 1 GB in size, where defined structured files must be less than 100 megabytes or less than 50 when read with the connectivity agent as they are brought into memory. Once you select the read file operation for the FTP adapter, you select a transfer mode where you'll want to use usually ASCII for structured files and binary for opaque files. Then indicate the directory location as well as the name of the file. Incidentally, just like the download file operation fields, the map action will later allow you to dynamically provide values for these fields as well. However, it is this next configure schema page that is quite different. If you select no, it means that you do not want to specify the structure of the file. If so, you're done. Just like the download file operation, this will be an opaque file to OIC, and it will only be transferred into the virtual file system, not into memory. But if you select yes, you will then be required to indicate how to define the structure of the file, since it will be brought into the integration memory as a data structure object. So one option is to provide an XML schema document which defines the structure of the file. Then on the Configure File Contents Definition pane, you simply drag and drop that schema. Then select the schema element that defines the file structure. Of course, if you don't have the schema file, a sample XML file will work as long as it defines only a single namespace or uses no namespace at all. And then you just select the schema element. You can also choose to provide a sample JSON document, then select the schema element, which will often just be the request wrapper. The final option is to upload a sample delimited file, which then allows you to define and build an XML schema based on the contents of that file. Now, we'll be covering the details of this option later in another video entitled Transforming Native File Formats. As to accessing the file, if you choose to read it without defining the structure, the response will be visible in the data mapper, providing you with only a reference to the file located in the integration's virtual file system. However, if you did define the structure, OIC will read in the file contents, which the data mapper will display in an XML schema format hierarchy, allowing you to access any data content within the file as shown in these two examples. Our final operation to discuss is the write file operation, where there are three general scenarios. One is to create a new structured file and then immediately upload it to a shared file system or FTP server. Now, alternatively, you can create a structured file, but then append those file contents to an existing file already in that remote file system. However, this is only possible for CSV type files. The third use case is when you need to upload an existing file in the integration's virtual file system over to the remote file system by providing the file reference. Now, once you select the write file operation for the FTP adapter, you again need to select a transfer mode where you'll typically use ASCII for structured files and binary for opaque files. Both adapters will allow you to specify which directory to write to, as well as a file name pattern, as shown in this example where we append a sequence number such as order1.txt, order2.txt, and so on. However, the map action will later allow you to provide values for these fields as well. For example, when you wish to define an explicit file name instead. Now, if the file already exists, instead of overwriting it, checking this box will allow the adapter to append the file contents, but only if the file format is comma-delimited records. If you have added and specified the appropriate public or private key and cipher algorithm when you configure the FTP adapter connection, you have these options for PGP encryption or decryption, as well as verifying signatures or generating signed files. And this checkbox must also be selected if elliptic curve Diffie-Hellman or ECDH keys are used. Next, just like the read file operation, you'll have the opportunity to define the structure of the file you wish to create and write to the file system, or choose to write an existing file reference as an opaque file. You simply choose from one of these same 4 options when specifying the structure. Finally, within the Map Action Data Mapper, if you choose not to define the structure, you'll map the appropriate file reference to this target element. However, if you choose to create a new file by defining the structure, you'll see the schema layout for all the data elements where you can now map the values you wish to populate for this file. And that wraps up this 2-part lesson on FTP and file adapter operations. Thanks for watching. Welcome. In this lesson, we'll learn how to interact with files located in the embedded file server using the new file server action. But first, as we learned in an earlier lesson, you can still define and configure an FTP adapter connection to interact with the OIC file server, just as with any other external secure FTP server. But when you use the file server action, under the covers, OIC uses internal APIs to directly access any location within the file server, unlike the FTP adapter, which has been configured with specific credentials. While the file server action functions similar to an FTP adapter connection, there are still some tasks where you would choose to use an FTP adapter instead. For example, when you need to bring a file directly into the integration's virtual file system and be made available in memory for processing. If you need to encrypt or decrypt the file, or if you need to sign or verify a signed file. These are all use cases for the FTP adapter. So what can you do with the file server action? Well, these are the 5 operations that are currently supported. We'll look at each of these in a moment. However, first, it's important to note that this action won't be visible to you on the design canvas of your integration if the embedded file server has not been enabled. It will just be grayed out as shown here. And so once your OIC service administrator has enabled the file server, of course, it will then be visible and available for your use to configure one of these 5 operations. The list directory operation is handy to use when you don't know the specific names of the files you're looking for. Once you select directory as the resource, you'll see the only choice for operation is list directory. And while you can specify the directory here, typically you'll be mapping that directory value in the newly added map action, such as a value from an input request parameter or an integration property or from a schedule parameter. You type an asterisk to list all files or choose a file name pattern to limit the type of files you want to list. The default is 100, but you can specify up to 1,000 for the max number of files to be listed. And if you don't want to list any files that have been just recently created or modified, you can indicate the number of seconds to compare against the current timestamp. A minimum age of 0 will list all files. And finally, checking this box will list all files that may exist in subdirectories of the indicated input directory. A common pattern would be then to configure a for each loop action where you'd use this file array from the list directory response as the repeating element for the loop. Now, once you name the current element, as in this example, you'll have it available in the sources section of subsequent expression editors or mappers where you have the file metadata to include each file name. For this next operation, you select File as the resource, then choose Get File Reference for the operation. Next, you most likely will use placeholder values because from the new preceding map action, you'll have the opportunity to assign those directory and file name values dynamically. And finally, once configured, you'll notice that the response from this operation returns not only the file reference, but will also echo that directory and file name as well. When you need to upload a file to the file server, after you select File as the resource, you choose Write File for the operation. Now, for these, you can use placeholder values, unless, for example, you know the directory will always be the same, but typically in the mapper, you will assign the directory and file name values dynamically. Notice that you will also need to provide a reference to a file that has been stored previously into your integration's virtual file system, such as from an external FTP server download, or a file that was created earlier within a stage file action, such as in this example. Now, this is a common pattern. When you need to transform or create a new file, then you wish to upload it to the embedded file server. Notice that in addition to the file reference, the name of the file created is used as the value for the output file name, and in this example, the output directory location was provided by an integration property that could have been modified prior to activation. Finally, once configured, you'll notice the response from this operation returns a Boolean value of true if successful, as well as the directory and the file name that was uploaded. To move a file to a different location in the file server, after you select File as the resource, you choose Move File for the operation. Next, there are placeholders for the source directory and file name, as well as the target directory and a target file name. But typically, once again, in the mapper, you will assign these values dynamically. Notice that you also have the option to overwrite the target file if it already exists. Now, once configured, you'll notice the response from this operation simply returns a Boolean value of true if the move was successful. And finally, to delete a file in the file server, after you select File as a resource, you choose Delete File for the operation, then specify which file in which directory needs to be removed. But typically, once again, in the mapper, you will assign those values dynamically. And once configured, just the same as the move file response, this operation simply returns a Boolean value of true if the delete was successful. And that brings us to the end of this lesson, where we covered how to configure and use these 5 operations of the file server action. Thanks for watching.
Welcome to this short demo on the native file server action that's available with OIC 3.2404 release. And first of all, let's look at a very simple use case I'm going to implement using that. Here I have my directory structure on my OIC file server. And as you can see at the top level here, or the level here, we have 5 files, 3 orders and 2 JPEGs. Now what I want to do is I want to move the orders to the sales directory, and I want to move the JPEGs to the marketing directory. And to do that, I'm going to use the new file server native action in OIC. So here we are in our project, and let's go into the integration that's actually going to do that for us. And once you have activated file server for your OIC instance, you will be able to use this action here. So let's just drag and drop this across to see what's actually available here. Now we will be dealing with 2 resources here. One resource is directory and the other resource is file. So for the directory, for example, I can have the operation list directory. So let's go back to our situation here. So I could say I'm going to start off at this directory level and list the contents of this directory. And I can also do like a recursive list that will go through all of the subdirectories and list the files there as well. So let's go back in here. That's directory. And now let's look at the file resource. So with the file, what can we do here? We can move a file, which is what I'm going to be doing in this example, but we can also read a file through getting the file reference. And we can use that reference, for example, to delete a file or write a file to another location, for example. So these are the operations that are available at file level. So let's go in here and look at the integration. Let's get rid of this guy here. We don't need it. And as you see, I'm starting off here by list, with list directory. And within here, you can see the configuration that I've done. I've said there's my top level directory. I can put in the file name pattern, and you can see how many files, max files. I can use minimum age as well. This is useful for the timely processing of large files. You want to make sure the large file has been fully written before you actually start processing it. And of course, the ability to list files recursively, which I don't need in this case because all of the files I'm interested in are in this top level directory. So if we go down here, we can see we've got a for each loop over the files read or the files listed. And as you can see here, here's the structure returned by list directory. So within here, you will have a file list, including the directory, file name, etc., etc. And of course, this is what I'm actually using as a repeating element here. So for the move, so let's see how this guy is configured. You will see here, this time we're using the file resource, operations move file. There's the home path, a directory, the source directory. I'm just putting in here a dummy.json because this will change every time because it's in a for each loop. And then there's the target directory, and again, the target file name. And as I say, you have the ability here as well to overwrite files if required. So let's go and try this out. So just do a save. Now I'm closing the integration. Now, I'm just after remembering I should have done the test, used the tester within the OIC canvas itself, but hey, it's too late. Let's go. I'll use that for the next demo. Okay, so here we go. Okay, this guy is active. Let's go in and let's run this guy now. So run. We see here it's processing away there, 4 iterations. And you see it's done to 5 and it's completed successfully. So we will see here for iteration 1, for example, we have all of these guys going through, moving it to media, to marketing, etc., etc. This guy is moving the order to the sales directory, etc., etc. So we can actually go back here and we can actually do a refresh at this level. And we see the files are gone from that level. Let's go into sales. Let's do a refresh at sales level. The orders are there. Let's go to marketing. Let's do a refresh there. The JPEGs are there. So it's a very, very simple demo. Thank you very much.
Welcome. In this lesson, we'll look to leverage the stage file action operations for processing files within your integration. So if you recall from an earlier lesson, once a file or file reference has arrived in your integration flow, regardless of which pattern is being used to trigger the integration or how the file was received, you can configure one or more stage file actions as needed using one of 8 operations. Now, these 5 operations are used on files that have been received, with the 2 read operations bringing the contents into memory so they can be parsed. These operations can be used just prior to sending a file out to an external system. The most common use cases are to leverage write file operations to create one or more new files, or to append content to create one new larger file. While you will most often retrieve files or file references from an FTP server or remote file system, you can also work with any file attachments or embedded content responses from SOAP or REST web services. So once you add the stage file action to your integration flow, the first thing you do is to select the operation. Then you'll be presented with the configuration options for that operation. Bottom line, the stage file action is similar in functionality to adapters. However, for a stage file action to process or act upon files or attachments, they must already be available in your integration instance. Let's now look at the functionality and how to use and configure each of these. We'll start with list files. This operation is used to return a list of files that have been previously unzipped into a virtual file system directory, or files that have been staged in a directory by other actions, such as previous stage file write actions. You can specify the virtual file system directory by name, or in many cases, as in this example, you will drag and drop a directory value that was provided by a previous response, such as an FTP download operation that also unzipped an archive. Specifying a file pattern also allows you to limit the type of files you're interested in, and checking this box will also list files that may exist in one or more subdirectories. Once configured, the typical use case is to follow up with a for each loop action so that you can iterate over each file to do some processing. Now, in order to configure the for each action, since the list files operation returns this response, you can specify the repeating element for the loop to be this object array called ICS file, which contains the file reference and the metadata for each file. While the FTP adapter can automatically unzip an archived file when it gets downloaded, there are times when the file is still archived, especially if it has been received by some other adapter, such as File, SOAP, or REST. And so with this operation, you can use the stage file action to do it explicitly when needed within your integration flow. On the configure operation page, there are two options. If you have just a file reference to the archive, you provide that here. Otherwise, provide the name of the archive file and the VFS directory in which it is located. Now, in both cases, you will then indicate where in the virtual file system to unzip the files. Later, when looking at the response in the data mapper, just like the list files response, you'll see that array of objects called ICS file, which contains the file reference and the metadata for each file. Once again, the FTP adapter has the capability to automatically create and send a zip archive of files located in a VFS directory. However, there are plenty of other use cases where you will need to create that archive ahead of time within the integration flow using the zip file operation. The configuration for this one is pretty straightforward. You identify which virtual file system directory is to be zipped, then specify a name for the newly created zip file, as well as another VFS directory where it will be placed. Later, when looking in the map editor, you'll see the responses from this operation provides easy access to the zip file reference along with its metadata if you need it. I'll cover these next two operations together. Once again, if configured appropriately, the FTP adapter can automatically decrypt a downloaded file and also encrypt or decrypt a file being written to the FTP server. But there will be other use cases, especially when you're not using an FTP adapter, where you'll need to explicitly decrypt a received attachment or perhaps encrypt a file before sending it out somewhere. But prior to you configuring either of these operations, someone with the OIC Service Administrator role must first upload the appropriate public or private PGP keys on the certificates page in the OIC Service console. To decrypt a file, of course, you'll need to select the private key, and to encrypt, you'll simply choose the appropriate public key certificate. Next, you will provide the reference to the file that is already within the virtual file system, then create a name for the new file along with the name of a VFS directory where you want it to be staged. Now later, when you need access, the new file reference is available within the operations response, visible in the map editor. And we'll conclude part one of this lesson here, as I will cover those three remaining operations in part two. See you in the next video. Well, welcome back. Let's continue with part 2 of configuring stage file action operations. We'll pick up where I left off in part 1. As I mentioned before, the write file operation is used to either create a new file or to create new content to be appended to an already existing file. Again, since this is not an adapter, the scope of this operation is to create file content that will be stored in the integration's virtual file system, which means you'll still need to configure an invoke role adapter connection to actually send the file to some external system from your integration. And just another reminder that all files in the VFS are automatically deleted once the integration flow instance has been completed. So once you select this operation, you will first specify a name for the file to be created along with a location in the VFS for it to be staged. If this is a file that already exists, checking here will append the contents, otherwise the file will be overwritten. Once again, just like the FTP and file adapter write operations, an append only works for delimited file types. You also have the option to encrypt the file here as well, choosing the appropriate PGP public key. Next, on the Configure Schema Options page, you'll notice that you must specify the structure for the contents of the file. This is required. And then you choose how to define that structure. Notice that these are the same options we learned about already in an earlier lesson on FTP and file adapter operations. There is an additional option internally. You can also create an electronic data interchange document. We'll revisit this one in just a moment. And as a reminder, the file size limit for a write file operation is 10 megabytes. Meanwhile, depending on which option you choose, just as we saw before, you simply drag and drop the document, then select the schema element. Now, for the CSV option, as I alluded to before, you'll learn how to do this in the Transforming Native File Formats lesson later in this module. And if you select the EDI document option, you only need to indicate the character encoding the file is expected to use. And finally, unlike all other stage file action operations, when you complete this configuration, a new map action will be added to the integration flow so that you can create the mapping to define the contents of the file you wish to write. In this example, I called the action create file, and I provided a purchase order XML schema of items for the file structure. Here's an example of what you'd see when you choose the EDI document option. In either case, it's up to you to implement the mapping to create the file contents as required for your use case. However, there is another use case to discuss. Well, most of the time you are creating a defined structured file, there is the scenario where you need to create a file using an opaque schema element providing a file reference, even to unstructured files such as a PDF or image file. Now, to handle this, you first create a simple schema document with just the opaque element, then select that as your schema file and schema element as shown here. Then when you open the newly created map action, you'll see the required opaque element that needs to be mapped. Expanding advanced functions, you drag and drop the encode reference to base 64 function, which is now added to the expression editor for that element. Now just locate the file reference and provide that as the function's argument. Moving on now to the read entire file operation. This one is almost identical to the FTP and file adapters read file operation, where you're essentially bringing the file into memory, in this case from the virtual file system, either a file reference or a file staged in a VFS directory. And you will be defining the structure of the file so that those schema elements can be made available as a source to provide mapping to other target data structures. So as an example, might involve first using an FTP adapter download operation to retrieve a zip archive and unzip the files into a VFS directory, followed by a for each loop action to iterate over each file. Then inside the loop, the stage file action operation is used to bring each file into memory one at a time, and then add one or more actions to handle whatever downstream processing logic is required from that point. So when you select the read entire file operation, you can either select here to then specify the file reference, or click No to specify the file name and the VFS directory where the file is located. Now, for delimited file types, here you have the option to remove the last row of data or even multiple rows. And if the file is encrypted, the content can be decrypted as it's read into memory by using the corresponding private PGP key. Finally, you now must specify the structure of the file, where you have the same 5 choices available we just learned about a moment ago with the write file operation. Now, as a reminder, this operation can only be used on files up to 10 megabytes in size. However, for larger files up to 1 gigabyte in size, this operation enables you to read the file in segments. Essentially, the operation creates a loop scope structure that delivers each file segment separately. Chunking files enables large files to be processed one logical chunk at a time, which enables the file segment to stay within those memory constraints. While this operation is most often used with delimited files with lots of rows, you can also read large EDI documents or XML files containing repeating elements and multiple namespaces. Here's a look at a common pattern where you first use an FTP adapter connection to download a file without defining the structure as an opaque file, so it can be up to 1 gigabyte in size. Then you add the stage file action and configure the read file and segments operation to retrieve that file from the virtual file system, now defining the structure and indicating the segment size for each chunk. Now you define a for each loop action to iterate over each record within that current segment, where you can then add one or more actions to implement logic needed to process each row of data. Remember that this operation scope is actually a looping construct itself, which will iterate until all the file segments have been brought into memory to be processed. So for this implementation pattern, you've sort of created a loop within a loop. Let's now look to see how this is configured. So when you select the read file and segments operation, just like read entire file, you can either select here to then specify the file reference, or click No to specify the file name and the VFS directory where the file is located. Next, you need to indicate the number of rows or records to process in each segment, anywhere from 200 to 2000. Now, since this is a loop, you have the option to process each segment in parallel, which is the default, or checking this box will ensure that each segment will execute in sequence, which may be slower, but it may also be necessary if your business use case requires that each record gets processed in order. And for delimited file types, just like read entire file, here you have the option to remove the last row of data or even multiple rows, where you specify how many rows at the end to be ignored. Finally, once again, on the Configure a Schema options page, you must specify the structure of the file, which is configured exactly the same as we learned earlier with the write file and read entire file operations. However, notice that there is a missing option since JSON files cannot be processed in segments. Now that the action is configured, returning to our example use case to configure the for each action. In this example, the file schema is a purchase order with many items. So each segment is already a subset of those items, anywhere from 200 to 2000, depending on your configuration. We will then loop over every item in the for each loop where we'll label each element as current item. Notice that when you need to access that item, it will be visible in the map editor sources section as a separate data object, where you can then extract any specific field value you may need to use for downstream processing. Finally, to wrap up this two-part lesson on stage file operations, remember that all files that have been read in, stored, or created in the virtual file system will automatically be deleted once the integration instance has completed. That's it for this lesson. Thanks for watching. Welcome. In this lesson, we'll explore how to handle the transformation of native file formats. When working with file data formats to be read into the memory of an integration instance, or to create a file within an integration flow to be sent out, we need to know its structure. So, as I mentioned in an earlier lesson, that when performing data mapping, all data structures are represented internally as an XML schema format so that we can use XSLT constructs to handle various data assignments. So you'll need to define the data structure when you're configuring FTP or file adapter connections for read or write file operations, or when there is structured inbound or outbound payloads used with SOAP or REST adapter connections. Also, within the integration flow, the read and write operations of the stage file action will require that you specify the file content structure. Here is an FTP Invoke configuration example, but both the file adapter and the stage file action provide a similar configure schema wizard. For the adapters, you must first indicate if you want to specify the structure. This is because sometimes your use case only requires receiving or sending the file as opaque, where you don't need to parse the data. But if you need to see the data in the map editor, you must define the schema. So when it comes to data that is already defined by an XML schema, if you have the schema, you simply select this option and upload the XSD. So OIC knows how to parse the data. Otherwise, if you have a sample of that XML document, choosing this option allows you to use it, and OIC will generate the schema. Likewise, if it's JSON, a sample JSON file can be used to generate the XML schema that will be needed. But what about native file formats? Well, if it is a delimited format, such as CSV, fortunately, you can use the file definition wizard to generate a native XML schema. With that option, on the Configure File Contents page, you just select the CSV file from which to create the schema. Immediately, you'll see the content of the file displayed at the bottom of the page. You now provide a record set name, which will become the root element of the created schema file, and the record name, which becomes the parent element in the schema for the record names selected as column headers from the CSV file. Now, while the default field delimiter is, of course, a comma, depending on the file format, you can indicate if it is instead a single space, semicolon, tab, or pipe symbol. The character set field is used for character encoding during file transfer. If data sent to the adapter is in a specific encoding format, then select that same encoding format in the adapter. Otherwise, there may be some character loss in the final written file. Now, this optionally enclosed by value causes occurrences of the selected delimiter to be really ignored during processing. For example, typically you would want to redact the double quotes or single quotes that might surround some string values in a column. And here you indicate how the end of each line in the file is terminated. To further edit the CSV file, you click here to expand the pane into full screen mode, which now allows you to see all the columns detected in the file along with the row values. If the column headers are in the first row of the file, you click this checkbox and they'll be picked up. Otherwise, the wizard creates these generic names, C1, C2, etc., and then you can manually edit those column names to be something else. By default, it assumes that all columns are mandatory, but checking this box will mark them as all optional, or you can separately indicate each one to be optional from here. Finally, here is where you designate the data type of each column if you need to specify something other than the default string type. When you're done, a summary page is provided. In this example, the configured FTP adapter connection will be reading in a file with that expected CSV file format. Then later, when using the map editor, you'll be able to see the retrieved file as a data source with that translated XML schema format, making it easy to do data mapping. This works the same way in reverse when doing a file write to create a new file to be sent out. However, what about other native files that don't use a strict delimited format? These use cases include flat files, fixed length files, or even more complex file types that can't be handled inside OIC using the file definition wizard. Now, to better understand the challenge, look more closely at this flat file example where each block includes one customer record with one or more associated account records, each with one or more transactions. Well, the solution is for someone to create a native XML schema file based on that sample file while applying the native file content definitions. This NXSD format extends the standard XSD format through the use of NXSD attributes. And since the XSD standard allows for extra attributes with their own namespaces, an NXSD file is a valid XML schema, which you'll be able to use in OIC, but more on that later. So while you could learn how to create this file manually with an XML schema editor, a better option is to use a tool to help generate this file. Which brings me to the native file, the native format builder, which is included in JDeveloper when you download the on-premises Oracle SOA Suite installation. Now, this is free to use for development, so you don't have to worry about being concerned about any licensing costs. The native format builder wizard guides you through the creation of a native schema file from almost any content format, delimited, fixed length, as well as more complex files that have records with multiple delimiter types. If you're going to use this tool, of course, you'll need to access the online documentation to dive deeper, since there are a whole lot of different use cases. And while it's beyond the scope of this training course to teach you how to use this tool, I will give you a quick idea of how it works. You start by indicating the type of file. Since you can handle delimited files in OIC, you'll likely be choosing fixed length or complex. Then you'll bring in a sample file to be parsed by the wizard. If it is a fixed length type, you'll be able to identify the position for each field location along with the names for each field. Complex types present both fixed length and delimited options so that you can build and design the schema to correspond with the native data. The wizard also provides look-ahead attributes that enable you to specify regular expression patterns for filtering both fixed length and variable length records. However, there are some cases where certain native files, such as master detail records, will require additional manual editing of the NXSD file. When you're finished, you can leverage the built-in testing tool, providing some native files to see how they are then converted against that schema to an XML file. You can also use XML source files to see how they are converted back into native. Now remember, in addition to reading native files, some use cases will involve creating new native file format files inside your OIC integration to be sent out. And with enough sample files testing in both directions, you can have confidence in your final NXSD file. So let's get back to how this will be used in your integration flow. When you're looking to define the schema, since this is a valid XML schema, you select the XSD document option, and when you click continue, on the Configure File Contents page, just upload the in.xsd file you created, then select the appropriate schema element, and you're all set. Notice on the summary page, it simply indicates the file content type as XSD. And that's it. You have the same options for transforming native file formats for either of these adapter connections, as well as internal stage file action, read file or write file operations. And that's it for this lesson. Thanks for watching. Welcome now to Module 7, Error Handling. These lessons focus on why and how to design beyond the happy path in your integration implementations. You'll learn about the OIC Error Hospital, implementing both global and scope level fault handlers, as well as the usage of fault and end actions. And once you complete these videos, don't forget to take the Module 7 skill check. Keep going strong. Welcome. To start these lessons on error handling, in this first video, I'll overview why you should implement fault handlers in your integrations, allowing you to design beyond the happy path. But first, you really need to understand what happens to runtime errors or faults when you don't implement fault handling logic of any kind. By default, every error that occurs at runtime is delivered to the error hospital, which is part of the OIC runtime environment that is hosting your deployed integrations. This will include any fault that happens. For example, an explicit runtime or business fault thrown when invoking an external service or system, or a runtime fault that occurs within the integration cloud, such as a request timeout or an invalid payload being processed. Internal processing errors are also caught, such as when you have incorrect data mapping logic that fails at runtime, or attempting to call a JavaScript function with invalid data. Bottom line, unless you design differently, everything is caught and delivered to the error hospital. Keep in mind, when the error hospital catches a fault, the integration flow stops immediately and it is terminated. And if your integration was designed with a synchronous application pattern trigger, since there is a client blocking awaiting a response, the error hospital automatically sends that error message as is back to the client as a fault. Additionally, errors and faults delivered to the error hospital will be visible to integration service monitors on the observability errors page, as shown here. Or when you're working within your project, these can be seen on the Observe Instances page. And when you think about it, this default behavior of using the error hospital works well, at least for many use cases. However, as an alternative to that default behavior, the best practice is to intentionally catch every fault that occurs at least once, because you can always rethrow a fault to the error hospital if desired. And I'll show you how that's done in another lesson. Faults are caught in the integration's global fault handler, or you can catch them within a specific scope fault handler. The fault will be caught by the closest fault handler in the integration flow to where the error occurred. But once it's caught, what should you do with it? Should you terminate the integration? Maybe. If it's a synchronous integration, should you return the fault back to the client? Maybe. Should you try to do something else? Well, that's the whole point. When you catch the fault yourself, the best practice is to do whatever the use case dictates. So then let's quickly look at 7 fault handling use cases you might consider. For example, maybe your requirement is to simply log the error because it's not that big of a deal. If the error doesn't impact the main processing logic, you might decide to resume the flow of the integration instance. Another use case may involve calling some other process or service to handle the logic if the primary service is unavailable. Incidentally, we have a hands-on lab exercise that demonstrates this scenario. Or maybe we log the error, but then because there's no reason to continue the flow, we now terminate it after we've caught the fault and logged it and perhaps sent a notification. Another option is to invoke another service that handles other forms of notification or other types of error processing logic. For synchronous application pattern integrations, maybe instead of replying back to the integrations client with the fault that was caught, you instead create a custom fault response, something that is more business friendly for the integrations client to consume. And maybe we're going to always send an email notification to some other external user or some administrator, and then from there we do whatever logic is required. Maybe terminate or maybe try to continue processing. Another more advanced use case is to have some other workflow that involves maybe manual intervention. We could put that logic in an Oracle integration process application using Process Builder, then invoke it asynchronously just prior to terminating our integration. Meanwhile, the process can take all the relevant information and get people involved with human-centric orchestration or other mitigation logic. This is only a short list of the kinds of things you could do. There are literally dozens of use cases and mitigation strategies you could employ. And we can't begin to cover them all here, but we just wanted to get you thinking about designing beyond the happy path. So to review, by default, when there is an error or fault at runtime, it is delivered to the OIC error hospital and your integration instance is terminated. However, the best practice is to catch all faults, then implement fault handling or mitigation logic as required by the integration use case. That's it for this lesson. Thanks for watching. Welcome. Now that we've discussed designing beyond the happy path, in this lesson, we'll look at one approach for doing that, implementing the global fault handler. Every integration has a global fault handler, and by default, there is already an implementation. You just can't see it until you open its design canvas. So to do that, located in the upper right menu bar above the integration design canvas, you click this icon, which will reveal the default implementation. Once the fault arrives, there is a rethrow fault action, which sends it as is to, you guessed it, it goes to the OIC error hospital. So if you recall from the previous lesson, I said that by default, all uncaught errors and faults go to the error hospital. Well, conceptually that is true because they all actually go to the global fault handler. And unless you implement different logic, they will go on to the error hospital. Well, in addition to uncaught errors and faults, there are two additional ways the global fault handler will receive a fault. One mechanism is to use the throw new fault action from either a scope fault handler or from the main flow itself, or only from within a scope fault handler. Once you've caught a fault, you can use the rethrow fault action to send it on to the next higher scope handler, which is usually the global fault handler. So at this point, we're going to encourage you to start thinking about changing the default fault handling logic to something that's more appropriate for your integration. Here are some examples. You can insert another action or two, such as a logger or a notification action. For synchronous integrations, you could create a custom fault message reply. Perhaps mitigate the issue by invoking a backup service. Or maybe there is another integration process or external service that is better suited to handle the error. Of course, we can't illustrate every possibility, but here's an example of changing that default implementation by deleting that rethrow fault action and replacing it with an explicit fault return action. We start with some fault handling logic within that scope container, then log some data, send an email, then map the data that's going to be the fault that gets returned to the client. Notice that in this implementation, nothing gets delivered to the error hospital. Over here in this scenario, we have a more sophisticated example of using conditional logic within the global fault handler. After deleting the rethrow fault action, we added a switch action, which allows us to implement error handling logic based on the type of fault that has occurred. The first route has specific fault handling logic for error X, followed by mapping a specific fault return message back to the client of the integration. The second route, for error Y, has logic within the scope that can mitigate the error, perhaps invoking an alternate service to handle the request. This is followed by mapping the data as a successful reply message back to the client. In the otherwise branch, which will handle all other fault types, we send an email notification, perhaps to an administrator, followed by the mapping of a fault return message. So as you can see, it can be a combination of things. The point is up to you to design the logic and decide what to do at the end. In this example, regardless of what type of error had occurred, this integration will never send an error to the error hospital because all faults have been handled. Which leads me to discussing the end action options and their behavior within the global fault handler, since you can't go back to the main flow. Let's take a closer look, starting with the rethrow fault action. Remember, this is the default implementation of the global fault handler, where the fault is rethrown as is to the error hospital. And if the flow has a synchronous client, that same fault will be returned to them as a fault message. However, you can choose to add additional logic, such as logging or notification actions as needed. Next, there are two different behaviors for the throw new fault action. In this example, as an end action, there is no skip condition defined, which means it will always execute. You'll configure this action to define a new custom fault, which will then be sent to the error hospital as the integration terminates. And once again, if this is a synchronous flow, the new custom fault message will also be returned to the integration client. The other way to use this action is with a defined skip condition based on any dynamic expression. In this example, if the condition is false, the integration terminates here, and the custom fault is delivered to the error hospital. Otherwise, if the condition is true, the action is skipped, and the rethrow fault action will deliver the original fault as is to the error hospital. And once again, if this is a synchronous flow, whichever fault message was delivered to the error hospital will also be delivered to the integration client. Next is the stop action, which is only available to integrations that don't have a synchronous client. This includes event and schedule pattern integrations, as well as the one-way asynchronous application pattern. In this example, the plan is to handle the fault by performing mitigation logic within that scope. Then once we're done, we simply end the integration flow. In this case, the error hospital won't be involved at all because the fault has been dealt with. However, we could also add a conditional throw new fault action as shown in this example, where perhaps under certain circumstances you deliver a custom fault to the error hospital. Exclusive to two-way synchronous application pattern integrations is the fault return action. In this case, once you've completed your fault handling logic, you explicitly map the data message content for a business fault to be returned to the client, which ends the integration. Once again, the error hospital is not involved because you've handled the fault. And finally, also there's the return action, which is also only for synchronous integration flows. In this case, you deal with the fault by maybe executing other mitigation logic, perhaps invoking a backup service, then map the data for a normal reply message to be sent to the integration client. And of course, once again, the error hospital is not involved because you've handled the fault. So to wrap up, since every integration has a global fault handler, it is up to you to implement error handling logic if you wish to supplement or override the default behavior of sending that fault to the error hospital. That's it for this lesson. Thanks for watching. Welcome. In this lesson, we continue our discussion on error handling by focusing on the implementation of scope fault handlers. While you can do all your error handling in the global fault handler, the better approach is to put most of your actions into separate scope containers, organizing the actions with related invoke configurations. Then you can implement the fault handler for each scope, defining error handling logic specific for that scenario. Conceptually, for those of you with programming experience, this works much like a try block of code with a catch statement, where any runtime or internal error that takes place during the execution of any action or invoke in the scope will be thrown into its fault handler. There, you can add and configure one or more actions to implement the error handling logic specific to this scope, instead of doing it in the global fault handler. However, to be more accurate, in addition to the scope's default fault handler, which actually functions more like a catch-all, in many cases there can be one or more additional fault handlers that will catch only a specific fault type. And this will depend on the type of adapter being used within the scope. For example, if there is an invoke to ERP Cloud within the scope, in addition to the default handler, you'd see a handler for an ERP Cloud service exception. Likewise, there is a service exception for Oracle HCM Cloud, as well as other Oracle application adapters. Some application adapters, such as Oracle Service Cloud, actually support the handling of more than one additional fault type. If so, you'll see those listed as in this example. Also, if you decide to invoke more than one application within the same scope, you'll have access to all their specific fault handlers, again, in addition to the default handler. Which leads me to the implementation. If the scope provides one or more fault handlers in addition to the default handler, as in this example, you can choose to implement one of them, or all of them, or only the default handler, or none of them. If the default handler is implemented, then it will catch all faults, unless you have also implemented the handler for that specific runtime fault. In that case, it would be handled there. And as a reminder, if a runtime fault occurs and there is no implemented scope handler to catch it, the error will be thrown on up to the next higher level fault handler, which is usually the global fault handler, unless the scope is nested and its parent scope has an implemented fault handler. Okay, let's look at this more closely. To summarize, faults are always caught by the closest and most specific implemented fault handler to where the fault occurred. In this example, if fault A occurs, that scope's fault A handler will catch it. If that one wasn't implemented, then the default handler will catch it. Now, if that wasn't implemented, then the outer scope's default handler will catch it. And if it wasn't implemented, then the global fault handler catches it. And finally, unless you change the default implementation for the global fault handler, that fault will be rethrown directly to the error hospital. The other question that arises is this: what if a fault occurs during the execution of an action inside of a fault handler? What happens? Again, the fault handler hierarchy is applied. It will be thrown to the next level handler if implemented. Notice, of course, that once you're in the global fault handler, the next level is the error hospital, and there is no other means of mitigation, which underscores why you should use scope fault handlers as much as possible. So it's up to you to decide what logic should be at the appropriate scope. The best practice is to catch errors as close to where they occur as possible. That way, you can have more specific fault handling logic or mitigation logic that you can implement accordingly. To implement a scope level handler, click the Scopes menu icon, then expand Fault Handlers, which will display one or more handlers, again, depending on what has been implemented in the scope. Now, select the one you wish to implement, which reveals a new purple Fault Handler box, which is empty, where you can now start adding and configuring one or more actions. Now, once implemented, that box will remain displayed next to the main scope box. Notice that you can click the Scope Action menu again to perhaps select another fault handler to implement. Otherwise, it remains unimplemented, where in this example, all faults are being caught by the default handler. In most cases, you're going to need to access the fault itself, so the OIC runtime provides a special fault data object, and you'll see it among the other data objects under Sources when you're doing your data mapping. If you're in the global fault handler, it is called Global Fault Object. And if you're inside a scope handler, the name of that scope will be reflected as the name of the object as shown in this example. From here, you can access any of these values as you see fit in your data mapping, the error code, or the reason and details strings. Be aware, however, that once a fault is caught, this fault object will only be visible while you're inside the fault handler. If for whatever reason you want to access that data later on in the flow somewhere, you would need to copy the data to a global variable that has visibility throughout the integration instance. Also, if you want to get more sophisticated, you can even do fault handling logic inside a fault handler by adding scopes, as opposed to letting the error be thrown up to a higher level handler. Remember, I discussed nesting scopes. Well, you can also nest a scope inside fault handlers, which means the nested scope can have its own fault handler implementation, and each fault handler can have additional scopes inside of them. Again, there is no limit to nesting. Of course, after so many levels, this could get complicated, but it's up to you to decide, depending on your error handling use case. However, I would recommend caution in these more complex scenarios. Instead of many layers of nested fault handling logic, a best practice, if possible, is to design one or more separate error handling integrations that you could invoke using the local integration call action. The idea is that you create these utility integrations that perform some sort of specific fault handling logic, then you could call it from your fault handler as opposed to having to embed all that logic nested inside of your integration flow. And some of these could also be reused by other integrations. So then, how do we end the fault handler? If you recall from the previous lesson on the global fault handler, I discussed these 5 end actions and their behaviors, and as you can see, these are the same actions you can use in the scope fault handler. The big difference is that while the global fault requires an end action, a scope fault handler does not. The last action in the fault handler can be anything, which means you don't have to use an end action. Instead, if you don't, the integration flow will simply continue on to the next action outside the scope. Which leads me to review the concept of fault mitigation. If the fault is minor or you have the means to mitigate, you certainly don't have to terminate the integration flow. You don't have to select an end action, which in effect says, yep, there's an error that has occurred, we must stop the integration. The whole point of designing an error handling strategy is to consider more options than just logging and notifications. Maybe we can work around the issue. Maybe we can call a backup service. Maybe we can fulfill the use case in some other way. So whatever your mitigation strategy, just remember that when there is no end action, the flow will continue to the next action outside the scope. If it is a nested scope, it would be the next action after the child scope action in the parent scope. Bottom line, when you're doing your integration design, a best practice is to add invokes and most other actions inside a scope action container, then implement one or more fault handlers. That's it for this lesson. Thanks for watching. Welcome. In this lesson, you'll learn how to configure the throw new fault action. You can use this action anywhere within the integration, but where you use it will, of course, determine where the fault is thrown. If used inside the global fault handler, the new fault will be sent on to the OIC error hospital, and if the integration is a synchronous request response flow, the client will get a copy of that fault as the fault reply. If used inside an outer scope fault handler, it will be thrown up to the global fault handler, and if used within a scope container, it will go to that scope's default handler if it is implemented. Or if you put it on the main flow path that's not inside of a scope, as you would guess, it would go up to the global fault handler. Now, since we've already learned about how to leverage global and scope fault handlers, let's now look at why you might choose to use this action. Typically, the reason falls into one of two general use cases. The first one is when you wish to send a custom fault reply to an external synchronous client, as opposed to them receiving whatever runtime fault may have happened within your integration flow. The other is where you might encounter an unexpected condition at runtime, such as data validation errors discovered within downloaded files or other externally received messages, and now you wish to raise that as a processing logic error that you want to deal with inside of a fault handler. So how do we configure this action? Well, it's a bit more interesting because it has something known as a skip condition, but I'll get to that in a moment. Once you add the throw new fault action to a location, the configuration pane appears from the right side of the design canvas. Here you click the pencil icon to provide a name for it. I used processing error for this example. Then below the only required field is the code, which can really be anything, a number or even a string if you wish. Now, if the intention is to return this as a custom fault, the best practice is to use a numeric error code that will have some meaning to the client. Then you can provide a string value for the reason, as well as a string message to provide more details. And then optionally, you can define a skip condition. Now, if this is left blank, that means the action will always be executed. Let's explore that a bit further. You can create a condition or a group of conditional statements that will dynamically determine if this action should be skipped. In this example, we're doing a data validation on an identifier provided by the client, which is expected to have a value of 1,000 or greater. So then this action will only execute, or throwing the fault, if the value is less than 1,000. Again, we're skipping the action as long as the identifier is greater than 999. But of course, you could combine additional expressions with one or more groups of or and statements, making the validation checking much more detailed. And finally, some considerations. Once you've implemented the logic for a skip condition, the integration canvas will show an arrow to the next action, as shown here, since there can be circumstances when that next action will execute. However, if you leave the skip condition empty, since the fault will always be thrown, a dotted line arrow is shown indicating that the next action will never be executed, which means you should almost never see this empty arrow pointing to another action in the real world. Instead, in those cases where you're always executing the action with no skip condition, it should be located as the last action within an execution block, such as within a fault handler or a switch routing branch, as shown in this example. Notice that in the Route 1 path, Action 2 will never be executed, which is fine. We'd only arrive there when the otherwise branch was used. And so that wraps up the remaining details for how to configure and use this throw new fault action. That's it for this lesson. Thanks for watching. Welcome now to Module 8, Additional Integration Topics. And as you can surmise from the title, instead of a primary focus area, the video lessons and demos in this module span a variety of topics, as well as providing additional information on other OIC capabilities and features mentioned briefly in earlier modules. Schedule integrations, using internal event pattern integrations, OIC observability features, more on projects, integration lifecycle and versioning, and other subjects. And there are also several videos that demonstrate the capabilities of the B2B feature in this module. And once you complete these videos, don't forget to take the Module 8 skill check. Keep going strong. Welcome. In this video, we'll take a quick look at OIC packages and contrast them to using projects. You should recall from an earlier lesson that one of the component resources available within OIC are packages. You can group one or more integrations into a package, which greatly simplifies those use cases where you need to export and import a group of integrations that are related to one another, because it also contains the integration's dependencies, such as connections, lookups, and JavaScript libraries. So rather than having to export and import integrations separately, you can export a package of integrations. However, except for that brief mention in the earlier video, you may have noticed that we haven't really talked much about these, and there is a reason. Packages have been available to OIC for a long time, but projects are new to this current OIC 3 version. So while packages are still available for use in OIC 3, Oracle now recommends using projects instead. So to better understand why, let's contrast the key differences between them. Packages primarily only offer help with organization. For example, you can collect related integrations in a single package. You can also import and export packages, including their contents. Projects provide those same capabilities, but they also provide many other benefits, including improved release management and a single unified workspace for designing, managing, and monitoring integrations. As to access control, everyone who works in Oracle integration can access the integrations in a package, just as they can access global integrations that are not part of a package. On the other hand, projects offer fine-grained access control. You choose the people who can edit, view, and monitor the integrations and other assets in each project. For deployment, creating continuous integration and continuous deployment pipeline and delivering updated integrations to higher environments requires work outside of Oracle integration. For example, you could export a package and use a solution such as Oracle Visual Studio, APIs, or shell scripts to move the integrations into a testing or production environment. On the other hand, the deployment is much easier and faster from a project. Projects provide built-in deployment capabilities for improved release management, including controlled and versioned deployments. So you deploy your integrations where you design them from within the project without the need to create a pipeline or run a build. Packages don't offer any separate monitoring capabilities. You can only monitor those integrations on the global observability pages. However, in addition to global monitoring, a project also provides observe pages for just the project's integrations. Monitoring within a project provides helpful context for those integrations. All of this helps you to understand why we won't be promoting the use of packages any longer. They're still supported. It is just that projects can do so much more. The good news is if you have packages that you've imported into OIC 3 from earlier versions, you can easily convert them to projects using the package conversion tool. Just navigate to your package on the Packages page, then from the Actions menu, select Create Project. It's that easy. This tool creates a project that includes all resources in the package: integrations, connections, lookups, and JavaScript libraries. Also, since the existing package remains untouched, once you have your new project, you can safely delete the package. Incidentally, this conversion option is only available for user-developed package integrations. You won't be able to convert older accelerator or recipe packages into projects. So to wrap up, while packages are still supported, Oracle is recommending that you focus instead on using projects. That's it for this lesson. Thanks for watching.
This one we're going to look at working within a project, designing your integrations, etc. Also project deployment and project observability. So you can see the three links we have here: design, deploy, and observe. Let's go through them and see what's on offer here. Now, of course, as already mentioned, the integration artifacts I see here are within the project and are only visible within the project unless I've granted access to the outside world. Now, creating the integrations is the same as creating the integrations outside of a project, with one difference here. And you can see here this checkbox where you can check and make this available to other projects. So this integration could conceivably be called via local invoke from another integration, be it within a project or outside of projects altogether. So we see here integrations, connections, the exact same thing. Everything here is created inline, making it very, very easy for you to do all of your development work within this environment here. Now, just look at one of the integrations we created in an earlier video. This is the parallel checks. You can see here the run within this is very easy to run these integrations. Just click the button there, and this guy is starting to run. When we go back over here, we can now click on observability, or observe, I should say. And here you see, okay, the list of the integrations that have been run within the last hour. Of course, you've got the filtering thing here, sort by last update or name, and then the date range and whatever. And you can see here, of course, you know, production, as we know, is up to 32 days, audit 8 days, and debug is 24 hours. So you can see all of these highlighted here, plus more. And of course, I can check on whatever status the integration has and which particular style that integration is, and so on. What's also very interesting here is, let's just look at this guy here, is you have here the statistics that are available here at this level, at integration level. So you can see the minimum processing time, maximum processing time, average processing time, standard deviation, and so on. So you can see exactly the minimum processing time was 341 milliseconds. We see here that the maximum processing time was also 341 because we just ran this once here. But you get these interesting stats all over. So let's look at another one where we will have different stats. Let's go into this guy here. And you can see here, we can activate these guys here, and you see, okay, minimum, maximum was 634 milliseconds, minimum was 89 milliseconds, etc. So very, very useful information that is available there. And of course, the percentiles, for example, 95% of these integration flows have completed within 634 milliseconds. Very, very useful information that we have here. Now, when I click on the Instances tab here, I get another view. And you can see this donut style control here to show the different status of our integration flows here. Now, okay, 94.7% have succeeded. One of them has been errored, but you can see the other status that we could have like aborted, queued, blocked, in progress, paused, resubmitted, etc., etc. So all of this information is available here within the project. And as I say, again, this observability is for the integrations within the project only. And of course, if I had future runs here for particular integration scheduled jobs, I could see them here. I don't have any at the moment, which means I can actually just go back in here. And I have a scheduled job here. Excuse me. Went back a step too far there. And here it is here, our friend here. And let's go in here to the schedule. So I can schedule this to run every day. Let's start the schedule. Okay, so we have that here. And just close that guy off there. And we can also here, track instances, delete the schedule, etc., etc. Let's go back in here now. And before we go, you can see here, repeats daily. So going back into our observability here, and we go to future runs. We see our friend here, ready there for execution on a daily basis. Okay. Yeah, different views are available there, but I suppose the one that's most important here would be the weekly view. As you can see here, that's for next day and so on. Okay, so we've looked at developing our integration flows, etc. within a project. We see there's no major differences there. Again, don't forget about the share option here. Per default, integrations are the integrations that you create within here are private, but you can at any point when, not at any point, but when creating an integration, you can decide to make it available to other projects. Now let's look at deployments. Now I've got a multiple integrations here. And from these multiple integrations, what I can actually do is I can create a deployment. Now a deployment is kind of a collection of versions of particular integrations that I want to deploy together. So I can create a deployment and I call it here OCW deploy 1. And then you can see here are all of the integrations that are available and along with their version number. So as you can see here with the finance check, I can say, do I want that? I say, I don't want the finance check. Or I say, in this case, I do want the finance check. I want the legal check here. Parallel checks, I want that guy there. Now imagine if I say that's all I want to release at this particular point in time. I can actually just go in for the rest here and then just say none, none, and so on. And with that, I can actually define, okay, what is my integration set, so to speak, and let's include this guy as well. We include that guy as well. Okay, so we just say V1 of Oracle Cloud World demo. So I've saved this now, this deployment, and it includes those 4 integrations that I selected. And of course, now I can go in here and I can, for example, export that. So I could clone that deployment, but I could also export that deployment. So let's export the deployment. It's going to be exported as developed. Now, where does this developed term come from? Well, it really refers to the fact that this has been developed by an OIC user. We will in OIC, and we have today in OIC, what are known as business accelerators, which are out-of-the-box best practice integration implementations for specific business use cases. So these are really Oracle developed, so they would not be shown here as developed. They would be shown here as Oracle. And then we can, of course, just export this. So now this demo has been, or this project, or this thing of the project has been exported. And as you see here, it has created that .car file. And this is something I mentioned at the very, very start when we're going in to create a new project. For example, here, I can then import a car file.
Welcome. In this video, I'll discuss the life cycle of integrations to include versioning and activation options. Let's start with the integration status. When you first create a new integration, it will be displayed in a draft status. Then once you've implemented any logic, when you save it, you'll see that the integration moves to a configured status. If you're in an edit session and your browser becomes disconnected, when you reconnect, you will see this locked status. Then when you unlock it, it will revert to the configured status. If you feel your implementation is complete, you can attempt to activate it, where it will show this activation in progress status, and then it will either transition to an active status if successful, or a failed status if there is an issue with the deployment. At this point, if it has failed, you would likely be troubleshooting to see what sort of issue is involved, why it couldn't be activated, and make some modifications to the integration or edit one of its connections as it goes back to a configured status. Of course, if you choose to deactivate an integration, it transitions through this deactivation in progress status and then back to a configured status. After integration design is complete, you can activate it and set the tracing level for your integration. You can click the Activate icon or select Activate in the Integrations Actions menu. You'll then choose one of 3 tracing level options. The production level is recommended because you get the best performance. It logs all actions on the main flow to the activity stream, as well as invoke and logger actions executed within loops of up to 1,000 iterations, and that data remains persisted in the OIC instance database for 32 days. The audit level logs the same data as the production option, but also logs the external full payload sent and received by your integration. However, this data will only be retained for 8 days. And the debug level, while certainly not recommended for production, is the one you'll choose to use while you are designing and testing your integrations. This option logs essentially everything to include all actions inside of loops, again, up to 1,000 iterations. However, with all of this data, the retention period is only 24 hours. Afterwards, there is only minimal data available stored about the integration instances, which is retained for 32 days. Now, once activated, if the tracing level is production, the status icon will show as active, while the other 2 tracing levels will be displayed along with that active icon as shown here. However, you can change the tracing level dynamically if needed. From the Integrations Actions menu, select Configure Activation, where you'll see a similar dialog box allowing you to change, even though it's already activated, to another option. Once you click Save, the integration status will be updated within a few seconds. Of course, if you need to make any modifications to an active integration, you will first need to deactivate it before you can edit. You can click the Deactivate icon or select Deactivate in the Integrations Actions menu. Now, this will stop the integration from processing any new messages, and for asynchronous patterns, the queue for the deactivated integration is also deleted along with any incoming messages. Therefore, if there are any pending requests unprocessed, they are lost after deactivation. Keep in mind that deactivation is equivalent to undeploying a project, which means all existing history, monitoring, and runtime data are lost. And since deactivation can take some time to complete after you initiate the request, during this period, there may still be in-flight messages being processed. Now, these processing instances will fail when the corresponding integration artifacts and resources are removed and undeployed. And you can observe, though, different processing errors for the failed instances depending on the point of processing during the deactivation. You can also observe the failed instances occurring after the deactivation request as well. One more caveat: the deactivation of an active schedule pattern integration is actually not allowed. So you will first need to stop the schedule, canceling any further runs. From the Actions menu, you can create a clone of any integration flow. Cloning an integration creates a new copy with identical connections and data mappings. You give the clone a new name, identifier, version number, but the remaining configuration is the same. You can then reconfigure the clone after you create it. Since the clone has a different identifier, it no longer has any tie to the original integration. This is a handy option when you wish to create a new integration and not have to start from scratch. Any integration in any status can be cloned, configured, active, failed, or even locked integrations. Another option is to create a new version. Since it is the combination of the identifier and the version number that makes an integration unique, this approach allows you to essentially create a draft, which is also a new copy, but with the same information for the integration. Unlike a cloned integration, you cannot update the integration name or identifier. Instead, you must change to a different version number, choosing to make it a major or minor version of the same integration. From the Actions menu, you'll see this Create New Version option, and as with cloning, you can create a new version of any integration regardless of its status. However, there are some rules with regard to activating minor versions. Since they are tied to each other with the major version number, only one of them can be active at any given time. Also, when you do try to activate an integration sharing the same major version, it will automatically deactivate the current active integration. In this example, once I activated version 102, version 101 was deactivated and reverted back to the configured status. On the other hand, when you use a new major version number, as shown here with version 2, it can be activated without any impact to another major version, since it is now a completely independent service. Now, the reason for this, if you look at the unique URL for an integration along with the unique identifier, it will use only the major version numbers such as V1, V2, and so forth. The minor versions will all share the same URL. And finally, a word about locked integrations. When you have an integration open in your browser for editing, then if your local machine temporarily loses internet connectivity, or if a UI-related error has occurred, or if your session simply times out due to inactivity, the edit screen you're working in, such as the integration design canvas or an edit pane or the map editor, it will freeze and your mouse actions will be unresponsive. And at this point, your integration has become locked. When this happens, just close your browser and reconnect to the OIC Service Console. And when you navigate back to your integration, you'll see the status as locked. Now, good news. Now, from the Actions menu, you can now don't have to create a clone or a new version. Instead, just select Unlock. If there are no saved changes, you'll see this dialog box, and you just click the Unlock button. You can then proceed to open the integration for editing. However, if there are unsaved changes, the dialog box will offer two choices. You can either unlock the integration discarding any of those changes, or choose to re-enter the integration design canvas and attempt to recover those changes. You see, as you're editing an integration, a backup copy is created whenever you complete a task, such as configuring an action, deleting an Invoke connection, configuring business identifier tracking, or defining global faults. Now, the good news is there is no time limit in which you need to log back in and recover your changes. But unfortunately, some changes are not recoverable, such as when you're working inside the map editor or working on the configuration in the middle of an action. For example, when you're editing a stage file action and then lose network connectivity before you're finished. You'll also know in advance whether there are saved changes or not when you see this label before you even attempt to unlock. And that wraps up this lesson, where hopefully you've learned a little more about integration lifecycle operations. Thanks for watching.
Welcome to this short video on OIC observability, formerly known as monitoring. So here is my OIC3 environment, and as you can see here, monitoring is observability, and I can of course go in here and have an overview of the integrations running in this particular instance. You can see what's available here for us at a very, very high level. An overview here of errors, the error rate, success, aborted, etc., etc. I can, of course, go down here and have the individual integration view. And I can see here which integrations executed. And as I shown on an earlier video, we can look at stats for the processing of these guys here. So you can see the maximum processing time for this was 159 milliseconds, average 128, and the minimum was 98 milliseconds. So of course, we've also got the percentiles that we can check out here as well. So this is very, very useful for seeing, okay, what's actually happening with it within this OIC instance itself. We also have here, for example, subscriptions, where we can actually see which subscriptions we have here to OIC events. Now, OIC events, new feature introduced a couple of releases ago, allows us to have pub sub within OIC. For example, publish a new event, order created, and then of course I could have other integrations such as this one here, sub new order, subscribing to that event. And of course we have the new integration pattern events, which are used for creating such subscriptions. Okay, there's our connectivity agents, and then we can go down and look at the individual instances here. And of course, errors, future runs. This is for scheduled jobs to check out what our schedule is like, B2B tracking, and also here, very, very interesting, is Fusion applications. So here we're looking at business events from a Fusion apps perspective. As you know, for example, Fusion ERP has up to, I think, about 170 business events. Events such as purchase order created, purchase order updated, etc. And of course, I could have integrations that actually subscribe to those events via the ERP adapter. And here I get an insight into that based on the Fusion connection. So I can see, based on this Fusion connection, which integrations do I have subscribing to which business events. So again, this observability, great widgets that we have here, very much salient information. For example, focusing on the errors, because we're not really interested in all of those integrations that completed successfully, but we really do want to hone down on the errors. So it's very, very easy for us to actually go in there, drill into the individual errors. For example, here are the two errors for that particular integration, this Salesforce integration here. But where I want to go to with this here is, what have we done, or what can you do above and beyond OIC? And this is where we come into the area of OCI logging and OCI logging analytics. As you know, it's very, very easy from an OIC perspective to enable OIC activity stream logs to be sent to OCI logging. And then I can easily view those logs for a particular OIC instance or group of OIC instance. And it makes it very easy for me to go in here and then to actually check on a particular instance ID. So I could go instance ID, and let's go into our friend here. I think this is the environment I should be looking at here. Yes, and let's get an integration flow from here. Just get an instance ID, and there's one there. Let's check out this guy here. So I copy that. Let's go back into our friend here, and we do data.instance ID equal to control V. Then just press enter to get that query in there, and I can just do a search based on that. And let's do it. It's going to be the past hour. And there I find all of the logs for that particular integration instance there. So very, very useful here as well. So of course we can do that within OIC, but here of course we have the added capability of not just looking at one OIC instance, but multiple OIC instances. So the whole idea here is the log files from OIC, or a subset of the activity stream logs, I should say, can be sent to OCI logging. And from there, via a service connector, I can pass that data onto OCI logging analytics. So what does OCI logging analytics give me? Well, I'll just show you here, for example. Here is a dashboard, and it's one of the out-of-the-box dashboards that the OCI logging analytics team ship with their product. So there are 3 OIC dashboards. We look at all of them, but this one here is essentially the health overview. And as you can see here I've got one OIC environment, and in my other browser here's a different OIC environment. So again, managing those 2 guys can be done on an individual basis, or here I am within OCI logging analytics, and I see the 2 environments. I see how many integrations have been executed, how many discrete or distinct integrations have been executed, and how many instances I have. As you say, I'm looking here, or as you can see here, I'm looking here over the period of the last 2 hours. And I can see how many do I have in the error hospital, like resubmittable flows. And this other widget is showing me actually which errors are in there. And then I have another widget here showing me, okay, which errors have actually been caught. Interesting as well here, instances by environment. So I see I've got 2 environments here, but only less than 1% of the integrations are actually executing here, while the majority are actually executing up here on this particular instance. And what you see here is the OSIDs of those particular integration instances. Now we have the breakdown then of instances by instance integration ID or identifier. And you can see here essentially what are my most popular integrations in this respect here. Going further down here, I can see the number of inbound requests, the inbound request processing time for specific integrations. I can check those out. The number of outbound requests from those particular integrations, the outbound request invocation time for specific integrations, etc., etc. Coming down here further, we see, and this is one of the big value adds of logging analytics, is this potential issues widget. And you can see here 4 new issues and maybe some no outliers, which is good. Now, an outlier is a logging event that occurs just once. So you can well imagine we're doing very intelligent parsing of the log file to come up with these things. With the new issues, it's parsing for errors, warnings, etc., etc. So giving you then, I'm breaking these into clusters so that you can see, okay, I've got many related errors or warnings, and I have the possibility exactly here to drill down into those and into the individual instances within those clusters, so to speak. Now, another thing to note here is when we're looking at this dashboard is you can drill into these dashboards. So I'll just give you an example here, like for the flow count in OIC Error Hospital. When I actually click here, it brings me into what we call the Log Explorer. So you can well imagine all of these widgets are being fed by log queries. And this is the query language that we have here for this. And it's very, very simple. Check out the OCI logging analytics documentation for the actual syntax that's required, etc., etc. But you can see here, the dashboard here, you've got different types of visualizations available and so on. You can, of course, make changes, and then you can kind of, then save your changes or save your change as a new widget, etc., etc. So net, like what the logging analytics folks are actually giving us here is something that is highly configurable. So it really is up to yourselves to just invest some time and effort here and making these really your own. So example, these are the widgets that we think are very salient for all of our OIC customers, but you can extrapolate from these and create more widgets, more dashboards, etc. Now, very important as well here is when we're talking about fleet management is the fact that I see here, I've got my 2 environments, but I can actually drill down into those. So I'm starting off at the fleet level, but if I want to, I can drill down into a specific OIC instance. Now, the list I will see here, you see it's based on the OSID, so I do have to know which OSID is which. And then I can also even drill down based on the name of the integration. So this is great. You're getting the aggregated view over your fleet. You can drill down into specific OIC instances, and not just that, but you can drill down into specific integrations. And of course, the dashboards, all of these dashboards here will be updated accordingly. Now, if I go just out of here, just to show you the other dashboards that have been created here by the logging analytics team. One is here. This is the health overview. Now, what I've done here is I've just duplicated this and I've called it health overview fleet management, because now I have edit rights to this. So these are like read-only dashboards, but all you've got to do is go in and click on duplicate. Then you have your own version of it, and you can go in and amend to suit your own needs. So I look at the other one here, which is the key metrics. Now, the key metrics here are based on the service metrics from OIC. So again, within OCI, we have the OCI logging, but we've also got the OCI service metrics and their dashboards as well. And you can see the sort of metrics that we have here. There's my two environments, the number of inbound requests, inbound request processing time, etc., number of outbound requests, the invocation time, and so on. Now, you can see here, we can actually break that down, the outbound requests by adapter, because at a high level, it's probably not that interesting, the number of outbound requests and how long they actually take. But it would be very interesting to know, okay, what about the number of outbound requests to ATP or to Fusion ERP? Now, you can break this down even further and say, I want the number of outbound requests to Fusion ERP for a specific integration. And I want to know what's the mean execution time of those invokes and so on. So all of this information is possible here. So again, just see this. This is a top-level dashboard. You can go in, edit this to suit your specific needs. The final dashboard that we have in here is the the time-taken analysis. So within time-taken analysis here, again, this is a widget from Logging Analytics. It's intelligent parsing of the log file to work out, how long did it take for a specific integration instance to execute, and see that over time. So the whole idea here is that you get a feeling, okay, what are my top consuming integrations, so to speak? Now it's parsing the log. I apologize for it taking so long. As you can see here, wow, we've got a lot of stuff executing here. So as you can see here, for a particular integration, I see here AAEF async 2, time taken 21 minutes, 29 seconds. So of course, I can trace that over a period of time, and I say, okay, here it seems to be taking an awful lot less time. So you get those sort of, you get that sort of insight into it. How long is it taking on average for these things to execute? But that over a period of time as well. So you can work out your peaks and troughs for your integration executions as well. And again, this dashboard can be duplicated. You can go in and make changes yourself. You could specify, you know what, I'm not interested in every integration. I'm only interested in some key integrations, and you could amend the query accordingly. So again, the logging analytics is available to you out of the box. You go to observability and management. Within here, you see logging. So this is giving you access at OCI logging level, so to speak. This is where you would create the service connector that pushes those log files onto logging analytics. Here you see our service metrics. You can drill into the service metrics for your OIC integrations. And then here is logging analytics with its dashboards, the log explorer, etc. Another thing to note is in respect of observability monitoring is the ability to actually create alarms. Now, alarms are very, very interesting because maybe you want an alarm raised when a particular integration has been called from what may be a business perspective too many times within a certain period of time. So it is very easy to create alarms and base those alarms on the stats that are being sent from OIC to OCI. So going back here, okay, it's great. Great insight here when you've got one OIC environment that you need to manage. We start off here at the high level dashboards. You can drill into the individual integrations. And as you can see here, we have these extra stats showing us the minimum, min, max, average, standard deviation, percentiles, etc., etc. But don't forget that we have then at logging analytics level and at OCI log level, the ability to do real fleet management. With that, I just say thank you very much, and I hope this has been useful for you.